Hey everyone, if you think geography is just staring at some dusty globe in a classroom and memorizing capital cities, well, get ready to have your perspective totally shifted. Welcome to this explainer. Today, we're diving into the really fascinating foundational tools of geography. We're going to discover how we truly understand the world around us and how the physical landscape literally shapes human existence. Let's get right into it.
Okay, let's kick things off with a big picture by asking two incredibly fundamental questions. Where are things located, and why are they there? These two simple questions are exactly what transformed geography from just rote memorization into this dynamic, analytical system for solving actual real-world problems. You know, it's not just about noting that a mountain is in a specific spot, it's about asking why that actually matters to the people living right in its shadow.
So, technically speaking, geography is the comprehensive study of the human and non-human features of Earth, our home planet. But honestly, it's so much more than a textbook definition. It's the ultimate intersection of nature and humanity. We're studying not just the oceans and landforms, but the constant, ongoing collision between the Earth itself and the people who live here.
Here is the roadmap for today's explainer. We're going from the macro to the micro. Geography basics, pinpointing exact locations, the 5 core themes, the mapmaker's dilemma, and finally, modern geographic technology.
All right, part 1, pinpointing exact locations, finding our place on a massive sphere.
Now, finding our place on a massive 3D sphere is actually a monumental mathematical challenge. So geographers came up with two complementary solutions. First up is absolute location. Think of this as your exact mathematical coordinate on the Earth's surface, using degrees of latitude and longitude. The second is relative location, which, let's be honest, is how we all naturally speak in daily life. It describes where a place is relative to somewhere else. Like, if you tell a friend that Washington, D.C. is about 200 miles southwest of New York City, that's relative location. We're just using everyday landmarks to guide us.
So, to make absolute location work, geographers overlaid a global grid. You've got the equator running east-west, marking 0 degrees latitude, and the prime meridian running north-south through Greenwich, England, marking 0 degrees longitude. By intersecting these lines, they created this invisible, exact coordinate system across our entire planet, meaning you can pinpoint literally any physical spot on Earth using this grid.
Moving on to Section 2, the 5 core themes, making sense of all this geographic data.
Okay, so once we know exactly where things are, we need to figure out what those locations actually mean. Geographers use 5 specific themes, or ways of thinking, to answer those two big questions of where and why. These are location, place, region, movement, and human-environment interaction. Together, they give us a fantastic narrative framework to totally humanize raw geographic data. They essentially take a random point on a map and turn it into a living, breathing story about climate, migration, culture, and survival.
The real standout here is that 5th theme, human-environment interaction. This explores the constant give and take between humans and our natural surroundings. It completely explains our settlement patterns. I mean, why do you think over 50% of the world's population settles on or near seacoasts? Or why are 8 of the world's top 10 most populous cities directly on the coast? It's simply because people naturally gravitate to flat land, fertile soil, moderate temperatures, and, of course, access to water.
Just take a look at this aerial view of the Jordan River in Southwest Asia. We can literally see how humans have adapted to and shaped the land. Notice how those lush, green, cultivated fields run right alongside the winding water? It's a stark contrast to the completely arid, challenging terrain surrounding it. People have built their entire lives, their agriculture, and their economy around this single vital water source. That right there is human-environment interaction captured in a single photograph.
Which brings us to Section 3, the mapmaker's dilemma, flattening a 3D world.
So, while globes are great and perfectly accurate, they are completely impractical to carry around in your pocket or fold into a glove box. We run into a really fascinating scientific problem when we try to take all this 3D geographic data and put it onto flat paper. Think about it this way for a second. Can you peel an orange and then flatten that skin onto a table perfectly without stretching or tearing it? The answer is absolutely no. Because the Earth is round, trying to flatten it out creates the exact same problem. And this perfectly explains why every single flat map you have ever looked at has some level of visual distortion. You're always losing accuracy in either the size or the position of objects.
To deal with this unavoidable distortion, mapmakers invented different projections. Notice that Mercator map on the right?
It's great for keeping the shapes of land masses accurate, but it hugely distorts their sizes near the poles. It makes Greenland look artificially massive, almost the size of Africa. But here's the reality check. Africa is actually 14 times larger than Greenland. Meanwhile, the Robinson projection on the left is more of a compromise. It shows nearly the correct size and shape, but it distorts the edges. It literally forces mapmakers to choose which geographic truth is most important for what they need at that exact moment.
And finally, Section 4, Modern Geographic Technology, from clay tablets to satellites.
Our tools for solving these geographic dilemmas have evolved dramatically, and it is absolutely incredible to track this progress. We've shifted from the oldest known map, literally carved into a clay tablet way back in 2500 BC, through hundreds of years of painstakingly drawn and printed paper maps, all the way to today's instant satellite-driven navigation. We literally went from scratching in the dirt to launching technology into orbit just to figure out where we are.
Today, the two main pillars of this technology are GPS and GIS. We rely super heavily on the Global Positioning System, which is a network of 24 satellites orbiting the Earth twice a day, just to pinpoint our exact, absolute location anywhere on the planet. But the real magic? That happens with GIS, or Geographic Information Systems. These computer systems allow governments and businesses to layer massive amounts of data, like road networks, business locations, or even moving storm systems, directly onto those exact GPS coordinates.
So, as you can see, geography isn't just something up in space or stuck in a textbook. It's exactly how you navigate your daily life. To wrap up this explainer, I want to leave you with a quick challenge. If you had to draw a mental map of your neighborhood from memory right now to help a friend find their way, what boundaries would you set? What relative locations and specific landmarks would you choose to include? And, most importantly, what does that tell you about the environment you interact with every single day? Something you think about next time you step out your front door. Thanks for exploring with me.